is the idea of this block. This is a CCMT 12mm boring bar, SCLCR06, so it takes 6mm CCMT tools. This is the 10mm equivalent of that. That is the 6mm equivalent, sorry, 7mm equivalent of that. And this is a piece of 5mm high-speed steel. It's actually tungsten high-speed steel, not molybdenum, which is the weird colour that you see on it. I'm not sure it's Chinese or English. It is come from an English, so it's probably T1 or T2 because they haven't put any kind of thing on it, so it's probably the least expensive tungsten high-speed steel. But by the by, it's 5mm. That is not 7mm, it's 6.94, so it's pretty rubbish. That is 9.99mm, so that's pretty good. And that I haven't measured. So once a hole gets big enough to put this bar in, I like to put that in because at present that's the biggest boring bar I've got until I get round to making a bigger boring bar. So on the Holbrook lathe I would use this. I would first drill a hole, then I would use this. I have got some smaller boring bars than that, and I would run this through on the same setting 5 or 6 times, and then stick another 1,000th on or half a 1,000th cut on, and then run that through 6 or 7 times until I stop getting the interrupted cut. So then I know the hole is absolutely true, and then I'll stick a drill through it again. And that's what I use these small ones for mainly. And they're very flexible. As soon as they go in the hole you can see the whole thing being pushed away, even only at that length there. So really I could do with making a shorter one, which might happen on this. Anyway, the point. If I put a 5mm hole through, I can just get 5mm high speed steel, grind the end on, or carbide, grind the end on, and I'll be able to, without too much effort, make small boring bars. So this will hold small boring bars. And on the other side, if I put a 12mm hole in it, at 5mm I can make a pretty decent sized boring bar, and even at that kind of stick out there it will still take a cut, although it won't be very good, and I can bring it out until the 12mm gets in there. Or I could sleeve up a 10mm, make a sleeve to fit in this, and put a 10mm or a 7mm into the sleeve. So I'm making the 12mm, I think, is what I'm going to be doing, although I haven't decided yet. You will see it happen before your eyes right now. Right, I can't decide. The decision cannot be made. So I have 2 choices. Another 2 choices. I think I'm going to make this 6mm in I don't think it really matters. Yeah, well, that's 6mm, first one, and the second one will be 12.5mm. Oh, 12.5mm. And then this one we should have 15mm on this side, I think. Yeah, 15, so half of 15 is 7.5. So we'll have 7.5 times 12 times 5 times 7. So that's what I'm going for, and you couldn't see any of that, but they are the measurements I've decided to go with. On, 0 it, 0, 0. Now, one of these momentum bits should be 0.025. So 2 should be 0.5. They are. Amazing, isn't it? Can you see that? Yeah, I think you can see that. So 3, yeah, you can't measure that. 4 should be 0.1, not quite. Let's go to 6, 0.15 that should be, not quite. 8 should be 0.2, not quite. 10, hmm, 2.5, 12, oh yeah, catching up. 14, 16, 18. So it's not bad, is it? And we want 3mm anyway. Do we want 3mm? No, I want 6mm. So let's stop messing about and go to 6. So we're trying to count them. Six mil. So that is 6mm in. Can't remember what I was 6mm in, but I'm 6mm in. Pretty certain I wanted to be 6mm in. I'm extremely certain. I wanted some extra meat on the outside, I think. Okay, here we go. Let's take the gauge off out of the way, and we'll stick a 7mm hole through at that side. Just tap the camera, it's very close to where I'm working, and now I'm moving you again because I'm touching the toolbox that you're attached to. Right, let's go for some drilling action. Goggles applied. Turn on the lathe and let's have some speed. Touch of oil. That is a centre drilled hole. Right, we're back. I have a 4.7 which is burnt up a little bit at the end, might not work very well, and a 6.7. But we will start the proceedings with this 4mm. So into the 3-jaw chock. And hopefully there's enough sticking out there. We will need 50mm. We've got 50mm there. Not quite. So just a little bit more sticking out there, about there. I'll tell you what, I'll give it 3 full contact points on the 3-jaw chock. And we'll see what that looks like. Okay, start off slow. Looks pretty good. Can you hear the lathe hunting at that speed? Just pick it up a little bit. installing the 4.7 that may or may not be a little bit burnt up at the end. Sure, we've got 50mm of stick out, 55, that's fine, ample. And let's give that a try. You can see this one come through as well. She's through. Okay, put it into low gear and we'll install the reamer. And there you have it, a 5mm reamed hole. These are all supposedly H7s, so there'll be a bit of a slack fit, which is alright. It means things will go in and come out. a boring bar holder. It can hold 5mm. Get it out, my fingers are too slippy. 7mm and 12mm. The 12mm is a little bit slack. It'll be fine. Now, I ain't sure, but I might be turning this around. I'm going to check centre height on it. I believe I have about 0.5mm extra on top, which I can take off. We could also measure it to give you an idea, to see if I am correct in my assumptions. So that's approximately 13mm. And that's a 13.78, so yeah. Those two holes drilled side by side are rather close. And I've left myself about 1mm of wall thickness. It's quite a straight hole, isn't it? I ain't done too bad. That's pretty good. Didn't use the DTI gauges or anything to line that up. So now I have 3 boring bar holders in one. Over the centre of the jaw, bring it into the centre of the jaw, and let's see if that locks up on that. Got some banging around there, or is that not the centre? So that was the way I had it, because that's perfect. Beautiful. There you go. She comes out of the hole. And she goes straight back in the hole, no fiddling at all, so that's definitely bang on centre height. Alright, the little boring bar holder is done. So first things first, I've made little dust covers. These are made out of Delrin, acetal, whatever you want to call it. They're plastic. And they're nailed. And there's a close-up look at one of them. So just a little plug that sits on top of the grub screws. So 3 grub screws, that'll hold the bar in. Then, when I'm not using a bar, I don't want no dirt inside it, so I've made this plug. That can be held in by the grub screws and stop the grub screws from vibrating. Then the anti-chip plugs can go back into the surplus holes. One of them's a little bit tight, I think it's this one. I'll try that in there. Yeah, that's the tight one. I did these all in one operation. I just brought them down to 5.8mm, put the chamfers on, wound the threading tool into its full depth and did one pass on it. So that's that. And the plug comes out a little bit to stop chips going inside the ball there. Okay, on the other side you may have noticed there is a single Allen key. Well, that single Allen key, what that does is, obviously you can just slip that out of the way, but it is keeping the chips out of all of the holes. We're out of Allen keys to use now. Does that Allen key work, that one? Nope, it works, that one. Okay, I need another Allen key. So I've used 3 different sizes. I've used M4 here, M5 here, and M6 here. I'll get it in a second. So the M7 boring bar is held in by 4. Where did I put that? There we go. So that's that out. And the same as the 12mm, I've made a 7mm bong as well. And this is the first time I'm trying it, so hopefully it fits. Take some of these Allen keys out of the way. Now these threads could have been tapped a bit better, but they're good enough. Now it's the moment of truth. Does it clear the boring bar? Yes it does. Excellent. So I've made that from an 8mm piece of bar, and that just clears the 5mm boring bar, and it's only about 1mm at the end there, and that will keep the chips out. Yes it will. So I'll put them in nipped, and that will keep that in. And of course we've got grub screws in that to stop that from moving and holding in position. Okay, that's all that. Just loosen them off so it's nice and slack so it'll move. Will it move? Yes it will. Okay, so I shall put the bong back on again, the top bong. Oh, yes it is. So that'll keep the chips out of that mainly. They will keep the chips out of that, so operating it should be nice and easy. And I think I'll put that bung in the opposite way, but we'll see. I might face this down to about 1mm as well and put it in the opposite way, because it looks like chips might get in there when I'm using boring bars on this side. And let's face it, that bung doesn't need to be on that side. I've left the 5mm because I think I'm just going to put a 5mm piece of high-speed steel in with no flange on the end of it. But by the bar, above the 5mm, so I'll get a shot on that, I've stamped in a 5, above the 7mm I've stamped in a 7, and above the 12mm I've stamped in a 12. I've put SRL 20, just so we know it's made in 2020, and on this side, before I forgot which side was top and bottom, I marked top and bottom. And the top I used a straight edge, and clearly the punch set is not ideal, as I did these freehand and they turned out a lot better, apart from the M obviously. They were done with a straight edge, and the straight edge was parallel to the top. And everything else was done freehand. So there we go, little boring bar holder, got all 3 boring bars, and because of the bongs I've made for it, it will keep chips out of the unused boring bars, and you can insert just one at a time. Now I have the feeling, to be fair, I have a lot of snapped off taps and small drills that I save, so you might find that I put a 4mm right in the centre, because 4mm is one of the shank sizes of taps, and there may be smaller ones to hold drills as well here, so I might have a 3mm, because I've got a lot of scrap 3mm drills, 3mm reamed hole here, and then use really micro high speed steel boring bars for the truing up, which I was talking about earlier on. Anyway, this shaft here, well, this was the end of the lead screw which came out of the mini lathe, so I've reused that piece of scrap, and this was a piece of printer rod, so that's chrome moly or chrome vanadium, hence it's so shiny and nice. So I have just sharpened the 5mm tungsten steel. So I started off, I necked it down, you can see that, I necked it down a certain amount. I don't know exactly how much. 0.4 of a mil. So I've gone from $4.99 down to $4.60. Ish. Okay, so I took 0.4 of a mil off of the shank for approximately 32 mil, or let's say 30 mil. So this can do 30 mil bores. To make sure, yeah, this can do 30 mil bores. Then I reduced its width at the front down to 2.27. So what that'll allow me to do, that'll allow me just to tip it up a little bit, just to bring it up a little bit. Then from the tip there back down to the 4.6, so I've ground that back a little bit. So it's got a front clearance, and since that is 6 mil and it's 0.4 over 6 mil, you can work out through triangulation what that angle is. I ain't got a clue what it is. And then the front angle, that's around about 10 degrees, I should imagine that is. And then it's got a back angle down there. I imagine that's about 7 degrees. And it's got a nose radius. Then I've honed it. So it's been honed. As you can see, it was cupped, but now it's been honed. So I've been looking for a piece of steel, which means I don't have to use the drill chuck. As you can see, the drill chuck's in here now, the live centre was there before. And I found this. I don't know what it is, but it's got a hole in the centre and it's got some interesting facts. So the wall thickness there is approximately 2.5. Okay, and on the opposite side it's 2.1. And if you look at it, you can see it's skewy. So let's see how less piskewy we can make that. So we've got 2.1, 2.5. We've got 15 mil and 10 mil. So I propose let's take that out to 12 mil ID and see if we can true it up a little bit. 3-jaw true it up, not 4-jaw. Yeah, 3-jaw. Just a quick test. So I'm just going to make sure everything clears. I've gone through. That is all the way through. I'm just going to put the stop on. Oh, hang on, let's just touch everything. I'm just going to put the stop on so it doesn't go any further through than that, because we don't need it any further through than that. Let's get you zoomed in and let's see what the first cuts look like. Take the cardboard out of the way and bin that for a start. Okay, here we go. That is better. So we'll give it 2.5 hundredths of a millimetre. I think it's slightly touching still, so I'm just going to put some angle on it. So basically I'm just going to bring the block about 1 degree further around, and we'll touch off again. See if that's any better. This is 200th cut. Right, let's get a decent cut. So that's 1/4 millimetre cut. Another 1/4 millimetre. Another 1/4 millimetre. Sorry, I had to hit the camera then, I didn't want to drag it out. I wanted to keep it where it was. Another 1/4 millimetre. Steady it back up again. Another 1/4 millimetre on. And this time a bit more speed and a bit of oil. I think that's looking pretty good. Let's have a look. Right, it's 11.9mm. 11.88 where we're looking. I think you can see it. There we go. 11.8. I've touched it too many times now. Yeah. I think we'll take another point. I'm going to take a skim cut at the same setting, and that should bring it out to 12 now, I believe. So we'll take a skim cut, same setting, bit of oil, that'll be it. that was 0. Oops, done it again. Sound like a pop song. Oops, I'm doing it again. So that cuts beautifully now. Yep, 12.06, 12.04, 11.93, I'll take it out. And I'm just getting another measurement in there. And we'll have the first looks of inside it. I can do that without beating everything up. Yep, got it out. So that's the, you can see better than me because I can't see anything inside the camera lens there. That's the surface finish I've got out of that boring bar, and I'm getting some kind of glimpse out of it now, and that's pretty nice. Right, let me set you back up and we'll deburr it with the Noga and do some measurements on it and see if it's trued it up. Right, we have the Noga. Let's give it a quick deburr. Consider that deburred. So, .09, 12.06, so it's pretty round on that side. 12.10, 12.09, 12.10, flip it out again, ruler taper, 12.05, 12.06, 12.07. So ruler taper, that's not good. Obviously the tool pressure pushing itself away. I'll have to change the geometry a little bit more again, some more relief angle. I think I'm going to have to neck it down a little bit more, take a little bit more off of it. It's probably just chips pushing it away. Not bad. 1.4, 1.47, 1.5, 1.4, 1.5, 1.5, 1.4, 1.5. Well, not only does it look better than it did before, it also measures up better.